Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube. Good morning to the students. Today I am discussing about list of engine parts and material, method of manufacture and function. First one, the cylinder. The material is hard grade cast iron. Function contains gas under pressure and guides the piston. Method of manufacture, casting. Cylinder head, cast iron or aluminium. Main function is to seal the working end of the cylinder and not to permit entry and exit of gases on overhead valve engine. Casting and forging, piston, cast iron or aluminium alloy. It acts as a face to receive gas pressure and transmit the thrust to the connecting rod. Casting and forging. Piston rings, cast iron, their main function is to provide a good sealing fit between the piston and cylinder. Casting. Gudgeon pin, hardened steel, it supports and allows the connecting rod to swivel. Connecting rod, alloy steel. For small engine, the material may be aluminium. It transmits the piston load to the crank, causing the latter to run, thus covering the reciprocating motion of the piston into rotary motion of the crankshaft. Crankshaft, in general, the crankshaft is made from a high tensile forging, but special cast iron are sometimes used to produce a lightweight crankshaft that does not require a lot of machining. It converts the reciprocating motion of the piston into rotary motion and forging. Main bearing, the typical bearing half is made of steel or bronze back to which a lining of relatively soft bearing material is applied. The function of bearing is to reduce the friction and allow the parts to move easily. Flywheel, steel or cast iron. In engine, it takes care of fluctuations of speed during thermodynamic cycle. Terms connected to IC engine. Intake manifold, cylinder head, exhaust manifold, top dead center and clearance volume. Another one is the piston at upper limit of linear travel, cylinder and stroke, bottom dead center. Okay. The inside diameter of the cylinder is called bore. As the piston reciprocate inside the engine cylinder, it has got limiting upper and lower position beyond which it cannot move, and reversal of motion takes place at this limiting position. The linear distance along the cylinder axis between two limiting positions is called stroke. Top dead center, the topmost position of the piston towards cover end side of the cylinder is called top dead center. Bottom dead center, the lowest position of the piston towards the crank side of the cylinder is called bottom dead center. In case of horizontal engine, it is called outer dead center. Clearance volume, the volume contained in the cylinder above the top of the piston when the piston is at the top dead center is called clearance volume. An engine with L is equal to D is often called square engine. L greater than D, the engine is under square. L less than D, that is the over square. Swept volume, the volume swept through by the piston in moving between top dead center and bottom dead center is called swept volume. Total volume, that is the swept volume plus clearance volume. Typical values for engine displacement range from 0.1 centimeter cube for small model airplane to about 8 liter for large automobile to much large number for large ship engine. The displacement of a modern average automobile engine is about 2 to 3 liters, 2 to 3 liter. For a given displacement volume, the longer stroke allows for a smaller bore under square, resulting in less surface area in the combustion chamber and correspondingly, however, the longer stroke result in higher piston speed and higher friction losses. Compression ratio, it is the ratio of total cylindrical volume to the clearance volume. It is always greater than 1. Okay. Compression ratio 5 to 5 ratio 1 to 11 ratio 1. Modern spark ignition engine. Modern spark ignition engine SI engines have compression ratio 8 to 11. With compression ignition engine have compression ratio the range 12 to 24. Engine with supercharger or turbocharger. Okay. Supercharger and turbocharger. Various attempts have been made to develop engine with variable compression ratio. One such system used split between that extends due to exchanging hydraulic pressure caused by engine speed and load. Some of two-stroke cycle engine have been built which have a sleeve type or valve. The engine, the slot opening on the exhaust port, the piston where the exhaust port is fully closed can be adjusted by several degree of engine rotation. This changes the different compression ratio of the engine. Now, piston speed, the average speed of the piston is called piston speed. Piston speed is equal to 2ln. L is equal to length of the stroke, n is equal to speed of the engine in RPM. Average engine speed for all engines will normally be in the range of 5 to 15 meter per second, with large diesel engine on the low end and high performance automobile engine on the high end. There are following two reasons why engines operate in this range. First, this is about the safe limit which can be tolerated by material strength of the engine component. The second reason why maximum average piston speed limited because of the gas flow. Some other terms, that is the direct injection, indirect injection. Okay. Working cycle, actually an internal combustion engine can work on any one of the following cycle. One is the Otto cycle, another one is the diesel cycle. Otto cycle is the fuel, working fuel of the Otto cycle is petrol, and working fuel for the diesel cycle, that is the diesel. Constant volume Otto cycle. Otto, according to the name of the scientist Otto, OTTO. The cycle is so called because heat is supplied at constant volume. Petrol, gas, light, oil engine work on this cycle. In this case of a petrol engine cylinder, the proportionate mixture is drawn into the cylinder during the suction stroke. In a gas engine also, constant pressure or diesel engine, in this cycle only air is drawn in the engine cylinder during the suction stroke. This air gets compressed during the compression stroke and its pressure and temperature increases by a considerable amount just before the end of the stroke a metered quantity of fuel under pressure adequately more than that developed in the engine cylinder. Dual combustion cycle engine. This cycle is also called semi-diesel cycle. It is so named because heat is added partly at constant volume and partly at constant pressure. Now, the air pressure. Air is then compressed in hot combustion chamber at the end of a cylinder during the compression stroke to a pressure of about 26 bar. The heat compressed air together with heat of combustion chamber ignites the fuel. The fuel is injected into the cylinder just before the end of compression stroke where it ignites. Indicator diagram. An indicator diagram is a graph between pressure and volume. The former being taken on vertical axis and the latter on the horizontal axis. This is obtained by an instrument known as indicator. The indicator diagram are of two types, theoretical or hypothetical and actual. One is the theoretical and hypothetical and actual. The theoretical or hypothetical indicator diagram is always longer in size as compared to the actual one, since in the former losses are neglected. The ratio of the area of the actual indicator diagram to the theoretical one is called diagram factor. Four-stroke cycle engine. Four-stroke cycle auto engine. The auto four-stroke cycle refers to its use in petrol engine and gas engine, light oil engine, which is the mixture of air and fuel are drawn in the engine cylinder. Since ignition of these engines is due to spark. Otto cycle, suction, there are four stroke, suction, compression, working and exhaust. তাহলে inlet valve, exhaust valve, engine cylinder, connecting rod, crank, spark plug. Suction stroke. During this stroke, piston moves from top dead center to bottom dead center. The inlet valve opens and proportionate fuel air mixture is sucked in the engine cylinder. This operation is represented by the line 5-1. The exhaust valve remains closed throughout the stroke. Compression stroke. In this stroke, the piston moves 1 to 2 towards TDC and compressed. The enclosed fuel air mixture drawn in the engine cylinder during suction. The pressure of the mixture rises in the cylinder to a value of about 8 bar. Just before the end of this stroke, the operating plug initiates a spark which initiates the mixture and combustion takes place at constant volume. Both the inlet and exhaust valve remain closed during the stroke. That is the diagram of pressure and volume. Expansion or working stroke. When the mixer is ignited by the spark plug, the gases are produced which drive through the piston from TDC to BDC, top dead center to bottom dead center. Thus the work is obtained in this stroke. It is during this stroke when we get work from the engine. The other three strokes, namely suction, compression, exhaust and being idle. The flywheel mounted on the engine shaft stores energy during the stroke and supplies it during the idle stroke. The expansion of the gases is shown. Both the valves remain closed during the start of this stroke, but when the piston just reaches the BDC, the exhaust valve opens. Exhaust stroke. This is the last stroke of the cycle. Here, the gases from which the work has been collected becomes useless after completion of the expansion stroke. are made to escape through its exhaust valve to the atmosphere. This removal of gas is accomplished during this stroke. The piston moves from BDC to TDC and the exhaust gases are driven out of the engine cylinder. This is also called scavenging. This operation is represented by the line. The figure shows the actual indicator diagram of the 4-stroke Otto cycle engine. It may be noted that the line 5.1 is below the atmospheric pressure line. This is due to the fact that owing to restricted area of the inlet passenger, the entering fuel air mixture cannot cope with the speed of the piston. The exhaust line 4.5 is slightly above the atmospheric pressure line. This is due to the restricted exhaust passages. The loop which has a 451 is called negative loop. It gives the pumping loss due to the admission of the fuel air mixture. Removal of exhaust gases. The area 1, 2, 3, 4 is the total or gross work obtained from the piston, and net work can be obtained by subtracting area 451 from the area 1, 2, 3, 4. Another one. So this is the actual PV diagram of the 4-stroke Otto cycle engine. Diesel engine. As in the case of Otto 4-stroke cycle, this cycle completed in 4-stroke as follows: inlet valve, exhaust valve, connecting rod. There are 4-stroke. One is the suction, inlet valve open, exhaust valve close. Compression, both valve close. Okay. Another one is the working, both the valve close, power. Another one is the exhaust, inlet close, exhaust open. Okay, that is the 4-stroke diesel cycle engine. Here the suction stroke with the movement of the piston. Compression stroke, the air drawn at atmospheric pressure. During the suction stroke is compressed to high pressure and temperature to the value 35 bar and 600 degrees centigrade as the piston moves BDC to TDC. This operate is represented by 1, 2. Both the inlet and exhaust valve do not open during any part of the stroke. Expansion or working stroke. As the piston starts moving from TDC, a metered quantity of fuel is injected into the hot compressed air in fine sprays by the fuel injector and it of injected at the end of compression stroke, but in actual practice the ignition of the fuel starts before the end of the compression stroke. The hot gases of the cylinder expands adiabatically to point 4, thus doing work on the piston. The expansion shown here. Now, this is the diagram, theoretical PV diagram. Exhaust stroke, another one is the suction, 1, 2, 3, 4. Exhaust stroke, the piston moves from BDC to TDC and the exhaust gases escape to the atmosphere through the exhaust valve. When the piston reaches the TDC, the exhaust valve closes and the cycle is completed. The stroke is represented by the line 1.5, shows the actual indicator diagram or for a 4-stroke diesel cycle engine. It may be noted that the line 5.1 is below the atmospheric pressure line. This is due to the fact that owing to the restricted areas of the inlet passages and entering air cannot cope with the speed of the piston. The exhaust line 4.5 is slightly above the atmospheric line. Okay, so this is the actual PV diagram of 4-stroke diesel engine. Okay, so pressure volume diagram, exhaust, suction, compression, like that. Exhaust, this is the PV diagram. Okay, okay, thank you. Last, if you like my video, you have to subscribe. Okay, thank you.